Thanks a lot. Today I will be talking about bridge the gap from modeling to delivery. We've had some talks about this from different aspects already. Today I'm going to be covering this from the organizational structure and way of working perspective. First, a bit about myself. I'm Ertuğrul. I'm originally from Turkey, and I started working at ING, the Dutch bank. Maybe some of you know about it. It's present in whole Europe. I started working there 5 years ago as a data engineer in Turkey, and 1 year after that I moved to Germany. Now I'm based in Frankfurt. Let's go to the agenda. Today I will be first talking about the problem background, and then because as you might know, we are all from different industries, and in different industries we also have different maturity levels. So that's why we also face different problems. That's why it's really important to scope the problem and what we are trying to solve in this presentation. Then I will talk about the gap in analytic solution development. And I will also make a point about how important the training and the expected skill set are in analytics. And I will end the presentation with pace and analytics lifecycle. So let's start with the problem background. As you know, I'm in banking, right? So in banking, based on actually a World Retail Banking report from 2021, only 60% of the banks implemented 1 or 2 use cases from analytics. So this actually shows that banking is still in an infant stage in terms of analytics. We are still trying to get there to be more mature, and we are still trying to implement analytics more into the DNA of the companies. So having said this, so in banking, we also have then some problems when it comes to, of course, productionization of analytic solutions. And I'm going to show you this chart, I think, this graph. I think most of you know about this. When it comes to analytics, even in this room, I think everyone has a different idea what analytics use cases that you do and how you perceive analytics. So it starts with looking back, right? So what happened in the past with descriptive analytics, and then why did it happen? So we start actually questioning the reasons behind it, and then we go to another stage where we look at what will happen next and how we can optimize it further. So in this talk, I'm going to focus more on the parts after diagnostic analytics. It's because even in traditional companies, reporting and getting insights from data is quite implemented in the company. But the part that is more challenging is usually to bring in an analytic solution, like a machine learning model, to production. So that's why we will be focusing on that part. So let's start with a very basic thing. So in a traditional company, what happens is usually there's a subject matter expert from a business, and this person sends their requirements to a data scientist, and they expect that data scientists will solve their problems, and they usually come with a model, and they send back this model, but in the end, subject matter experts don't know what to do with it, because they actually don't have the technical knowledge and also the tools to be able to implement this on any level. So this worked in the past. How did it work? If we change this data scientist with a data analyst, right? And if you only talk about getting insights from data, this would have worked, because what the subject matter expert expects is only some kind of report, maybe. And I think this is a picture that you all know. Just when we saw in this other small illustration, this machine learning code, like the model itself, is only a small part of what is needed to really go to production, right? Even if we take other things into account, like let's say feature engineering, data collection, maybe testing and debugging, and maybe model monitoring into ML code development, we are still not at the half of the journey. We still have a lot of other things to actually achieve before we get to the production. So this also raises the question, why do we need to actually only focus on use cases, ML use cases, we should actually take a step back and we should look at the whole journey, right? So don't isolate the analytics solution, think about the whole journey. What does this mean? I think we also had some statements similar to this in other talks. Other companies started to look into more journey-based approaches. I'm going to explain what it means for banking in a minute. But for example, in banking, how we assess the success rate of a bank is based on recommendation rate. So we basically ask people, how likely you would recommend our brand to another person, to a friend or a colleague. But what we started doing now in banking, to also ask people on a application level. So let's say, how likely you would recommend our loan process to someone else? Like, how would you go to ING for a mortgage? So this is the now level that we are questioning. So I'm going to show you one very simplified customer journey. So customer journey basically starts at the moment that customer walks into a branch or a customer logs into an app to apply for a, let's say, loan, customer loan, right? And when this starts and it ends, actually, the time that this person gets the loan, and also it continues afterwards, it ends when the time that this person pays his whole debt back to the bank. So this is the whole customer journey. We are actually looking at only the first part of it, from the moment that customer applies until if she gets a rejection or approval. And usually in this journey, you send in some documents and to the bank. And in the bank, you need to somehow classify these documents and send them to a different department. So there should be some kind of classification of the documents. And later, these documents need to be also understood. And for that, you need to extract some information from these documents so that you can actually make use of this data. And after that, you also need to somehow send these documents to the loan process application. And perhaps this application also runs another model, which is credit scoring model in this case, to get kind of a score about the customer's probability of default, let's say. And then after this, perhaps this goes to another decision tree with some more information, and in the end you come to a conclusion if it's a yes or no. But even in this small journey, you actually have 3, maybe even 4 different analytics use cases. So if you also include, let's say, somewhere here a fraud check, if the documents that the customer sends are correct or real or not, you have 3 or 4 different analytics use cases, starting with classification of the documents, extracting information, maybe fraud check, and then also credit decisioning, credit scoring models. So that's why it's really important to actually not isolate your solutions into only developing, let's say, credit scoring models, because you need to know about the whole journey. Otherwise, let's say, there's definitely a difference between, okay, give us the best accuracy for this scoring model, and give us the best accuracy for this scoring model under these circumstances. Because the data that you might get maybe will be different in different flows. And let's say if we isolate this part and only develop the best credit decisioning model, and the data scientists come up with some different features that they want to include, and then it's not planned for the rest of the flow and it's not part of the data flow, this will set the project back quite some time to also include this data flow, especially in a large-scale company in which the IT is not at the heart of the company. So this is usually what happens. But I would like to take a close look at what's happening here, because we talked about, okay, sending requirements from the subject matter expert and getting a model back. But how did we come to this API, right? So we need to somehow maybe we need to containerize our solution, write a REST API, and do the monitoring of the application, do the monitoring of the model. So as we've seen, there are so many more things than just creating the model. And here we see the end goal, that the model is already being served. So what happens usually in the companies, there is kind of an analytics organization which is responsible for model development, have lots of data scientists, right? And then there's also the owner of this process, loan process. And these are the, let's say, perhaps the customer loan team with their own IT team. And these people are experts on Java applications. They're very good at their job, but they're actually hired to do only this job. And but then there's a problem, because there's a model being developed by the analytics team, and there's a process which is owned by business with their own IT team. But then what happens to who is responsible from containerizing and doing the all DevOps work of this model? So this was one of the gaps that we had. And for that, I mean, it's no surprise, right? There needs to be some IT capabilities within analytics organization, or some dedicated IT teams to work on also the productionization of analytics solutions. So there are different ways of doing this. One of the ways is having a production platform that offers easy to use and easy to develop models, right? And I think this, analytics is still in development, right? There will be always some models that need some custom changes. There will be always some things that will not fit exactly the best platform that you have. So the more important part is actually to create cross-functional teams with different skills, with machine learning engineers, data scientists, DevOps engineers, data engineers. I only focus on from a technical perspective, so there are, of course, business people, like customer journey experts are also included, but I'm now only focusing on what is really a burning issue. And another important part is upskilling the data scientists to also perform some IT tasks. Because if there's a gap, we should not only expect from IT people to come to us and help with everything, to hold our hand and productionize our model, but we should also understand a little what they are doing with this. So training people is the key, right? And this is also nothing new. I think I've been listening lots of chief transformation officers, chief innovation officers, chief data officers, and one thing that they're always talking about is the training. Because essentially, we are now a large bank. We are trying to implement analytics and on every domain in our bank. This is kind of a transformation. And if you think this as a transformation, analytics is just a new technology. Maybe in the future, there will be some more things to include in that. And just bringing a new technology to a company will not solve your problems. So you need to have the people with the right skill to actually make use of this technology. So that's why if you think the whole analytics transformation on a very basic level, just like a normal transformation, training is one of the keys. But it's not only data scientists, so not just learning some IT, like some DevOps skills or software best practices. It's also training the employees and also management to set the right expectations. Because usually, what people expect from analytics solutions is kind of a magic. You spend 3 to 6 months on your IT development for like an application, but when you say, okay, we need 3 months to develop this model from scratch with the data collection and preparation and everything, people are like, whoa, 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 it's too much, right? So then you need to actually also set the expectations right, so that people know that this will also take some time. And in the end, they just need to know what kind of value it will bring. And what do we do at ING? I want to also talk a little about this. I talked a lot about the skills and what is expected from people. So I just would like to show you from our career page what is expected from data scientists and machine learning engineers. But don't get me wrong, so we are not one of those companies who have these job postings with like surreal expectations and there's no way you can find these unicorns. It's not what we mean by this, because there are actually some things that are kind of unexpected, maybe from a data scientist or machine learning engineers to do. Let's say there are some obvious ones like problem definition, data collection and analysis, data preparation, knowing of some programming languages, of course knowing the way of working of the company, knowledge in machine learning tools and algorithms. But there are also some things like cybersecurity and some ops skills. There's also technical infrastructure knowledge of ING. So these are not on a level that we need to write our own firewall rules for the models that we are developing. These are on a level that we also understand what IT is doing after we developed our model, so that we can also be part of these discussions. Because, I mean, it's not fair, right, to expect so many things from a data scientist and machine learning engineer, but we are in a kind of special position between business and IT, so we need to speak both of their languages. So that's why we need to be able to define a problem on a business level, but we should also know some ops. So this is actually the career you all chose, right? And and what do we do to actually also, now I've talked about some problems, and I've talked about also bringing people to a level where we can actually create some cross-functional teams, and we can actually create delivery teams on personal level and structural level. But we also need to have some kind of a framework so that we can use to make this a success. And what we do at ING, we actually have one framework that is called PACE. It's our own invention, but it's nothing new. It's actually combination of design thinking, lean startup, and agile scrum. This is a framework that we are using at ING for innovation for years now. And the reason for this is this actually brings all the elements that we need to be innovative. So design thinking brings the empathy with the people. It brings the customer perspective. So it actually forces us to know what customers really expect from us. Then lean startup brings the stage gate approach. So, you know, I mean, in startup world, you need to always, you work from one stage gate to next stage gate, and you never know if you're going to get funded again. And this is also what we do for innovation projects at ING, because it's also important, if your project is not going to work, to fail fast. Otherwise, you are working on something that will not bring any value to anyone, and you're just spending your resources on this. And of course, agile is just our way of working, and it brings this iterative approach to make this also a success. If we have a look at the phases of PACE, we have discover, problem fit, solution fit, market fit, and scaling. So the most important parts are in this, like problem fit and solution fit, because this actually helps you to really understand what the customer's problems are. And it creates a number of possible solutions so that customers can actually choose from one of them. And then you can also assess if this solution will bring enough value to ING as well. And afterwards, you go to market fit, and then you identify the best market to launch your application. Or in this case, you can also, I mean, in solution fit, maybe you are doing a small customer interview, and with the market fit, maybe you are opening your application to a bigger crowd, and then you get some more feedback. And in the end, you go to scaling if you also pass the marketing fit. But what is really important in this, on every stage, like after discover, problem fit, solution fit, and market fit, there's a stage gate. So after so there's a new idea, it goes to a steering committee, and it needs to pass this. After that, you work on this problem for some time, you define your problem, then you go to the next stage gate. So this is actually what makes ING in innovation faster and also more agile. And now you're wondering why I'm talking about this, because this is something we use in innovation, and we thought innovation and analytic solutions are kind of close to each other. So we can also make use of this in analytics. But for that, we also actually have some other frameworks, right? Like CRISP-DM. It's a very, very generic one. It starts with business understanding and data understanding and goes to data preparation, modeling, evaluation, and then ends with deployment. And I'm sure all of you use like a derivative of this somehow. We also don't use this one, so we have another one. I was not sure if I can reveal it, so I put this one so that it's a bit more generic. But I mean, in the end, they're all the same. But we already have this framework, and then we have also PACE, how we can bring them together. So we worked on something like this to actually map the phases of PACE to CRISP-DM or your own analytics lifecycle. And in this case, you can actually check after every stage of your analytics lifecycle, also with the stage gates, so if you're on the right track. So this also helps you to actually helps you to fail fast, but also helps you to get the management buy-in. How does this do it? So we have these stage gates. After the discover, we need to have definitely a scoped challenge. And after the problem fit, we need to have kind of a validated problem. And when I say validated, this is validated by the management team who is going to pay for this product. And after that, we need to have validated solution. It also entails proposed architecture, defined go-to platform, defined MVP requirements, and plan for development. And the most important part is here, handshake with IT and business based on its success criteria. So this defined go-to platform might sound weird to you, but ING is a big-scale company, so in every country we do have different analytics platforms, and based on the solution that we are developing, we also need to choose sometimes which one is the best, if we should go to cloud or if we should go for on-premise, if we should go for, I don't know, another solution, a batch or streaming. So that's why defining a go-to platform is also one of the issues that we have. And after that, after the market fit, we have the validated production solution. And this is actually the point where we optimized our model already. And when we optimized our model, we know that this model is going to go to production. So from there on, there is no going back. I'm done. Just one last thing. So this is not the solution, right? You all have your own frameworks for innovation, frameworks for way of working, and you all have your own analytics lifecycle. So you just need to find the balance of what works for you. This is something that was the result of a transformation we went through last year, and it's working so far, and I hope this was helpful for you as well.